Hi folks, this is the next video for the year to pure. Oh, can you see the dog's paw? I'm not quite. Year to pure, we're looking at 9J, the connected rates of change. So this is just using the chain rule again. Example 27, we're given A. So of course I can work out dAdr, and we're also given dr dt, and I want dA dt. Well, of course I can't work dA dt out directly. I've got dAdr, so I'm going to use the chain rule, because of course my dRs will cancel out. So this, you can see that because I can multiply these together, these are equivalent. Well, that's easy enough. 2 pi r times 5, which is 10 pi r, and when r is 3, is 30 pi. So that's easy enough. Now, as it happens, it's area divided by seconds, so it would be centimetres squared per second, but they haven't asked us for the units. Example 28. What have I got? V 2/3 pi r cubed. So straight away I know I'm going to need dV/dr, so that's 2 pi r squared. S is pi r squared plus 2 pi r squared, which is 3 pi r squared. So ds/dr is 6 pi r. Now, what else am I given? I'm given dV/dt, that's 6, and I want ds/dt. So my fractions are going to have to start with a ds. Okay, so ds/dr. Well, I need to cancel out my dr, so I'm going to need a fraction with a dr on top. Well, that can be dr/dv, and I need something with a dt on at the bottom. Well, that can be dV/dt, and that works because the dv's also cancel out. So it doesn't matter how many fractions I've got, we can see that the drs and the dv's will cancel out. So ds/dr is 6 pi r. dr/dv, well, that's the reciprocal of dV/dr. So I'm going to divide by 2 pi r squared times by 6. So pi goes, one of my r's goes, 6 over 2, that's 3. So I've got 18 over r. And that's it. They don't give me a value of r, so that's 28 done. Now, 29, 30 and 31, we can't actually do much other than write down differential equations. A differential equation is an equation which contains a derivative. We don't know how to solve them yet, and we won't know how to solve them until we do the integration. In the decay of radioactive particles, the rate at which particles decay. So the rate indicates dt because it's time, so something over dt, and decay means it's negative, it's reducing. So the rate, so if n is the number of particles, the rate at which the number of particles decays is proportional to the number of particles remaining. Now, I could put a minus in, they have in the book. It doesn't matter, because of course if I solved this I'd find k to be negative. If I put a minus in, I'd find k to be positive. So a minus there is optional, I guess. Because it's a rate of decay, I probably would leave the negative in, which is why they've done that in the book. Example 30. Newton's law of cooling states that the rate of loss of temperature of a body, so let theta be the temperature, the rate of loss of temperature, so d theta over dt, which we know will be negative, is proportional to the excess temperature, is proportional to the excess temperature over the surroundings. And in the book they've used theta 0, where theta 0 is the ambient temperature. Again, you could have a minus in there if you want, because it says loss of temperature. Let's do 31. Example 31. The head of a snowman of radius r loses volume. Okay, so loses volume by evaporation at a rate proportional to the surface area. So the rate of loss of volume is proportional to, or it loses volume, proportional to the surface area. Well, S we're given 4 pi r squared. Write down the differential equation for the rate of change of radius of the snowman's head. So they want dr dt. Well, dr dt, that's going to have to be dr ds times by ds dt. So ds dr, 8 pi r, so dr ds is going to be 1 over 8 pi r. Yeah. The volume is, hang on a minute, so ds dr, the volume is 4/3 pi r cubed, so dv dr is 4 pi r squared. Right, let's have a think about this. I want dr dt. I've got dv dr and ds dr. Dr dt. I've got dv dt as well. So if I have my dv dt on the end, then I need a dv to cancel out there and a dr. Well, I've got that. So dr dv is 1 over 4 pi r squared. dv dt is minus k times s, and I know s times minus k times 4 pi r squared. So my 4 pi r squareds cancel out. So dr dt is minus k. So actually I didn't need ds dr at all for that one. Okay, 9J, enjoy yourselves.